All right, what's up, everybody? This is our first of a three-part series talking about surface area of three-dimensional figures, okay? And so each one is going to focus on a specific type of 3D figure, and then there's going to be a formula to go with that figure. Now, before we start talking about formulas or anything like that, the biggest thing to understand is the characteristics about that shape. So the first slide here is going to focus on what is a prism, what are the things that it's constructed of, what does it look like, etc. Okay? So a prism is a 3D shape made up of two identical bases and multiple what we call faces. So I'm going to be using the word base and face a lot throughout the next few videos. Okay, so a 3D shape made up of two identical bases and multiple faces. So the big thing here is to remember that with a prism, there are two identical bases. Okay, so here are some examples of prisms. So you have your triangular prism, square prism, which is also known as a cube, pentagonal prism, rectangular prism, hexagonal prism, and octagonal prism. And I think it's important to note that a prism gets the first part of its name from the shape of its base, right? So if we look at the triangular prism, notice that there's a triangle right here, and if you look at it three-dimensionally, there's one in the back, okay? Those are the bases, all right? Now, it's important also to note that there's other sides of our prism, right? Like this side right here, or the bottom here, or the other side here if we're looking at it three-dimensionally. Notice that those shapes are not triangles, okay? So this would be a triangular prism because there are two sides that are triangles. Now, if you're looking at a rectangular prism, that kind of changes a little bit because you have a rectangle in the front, rectangle on the side, rectangle on the top. So a rectangular prism, technically you could pick any two opposite parts and make it the base. But then if we look at our pentagonal prism, notice that there's only a top part has 5 and the bottom part has 5. All the other sides are rectangles, okay? And the sides that I'm talking about, like this side here or this side here on our triangular prism, those are the faces, okay? So the number of faces for a prism will be determined on how many sides your base has. So notice that a triangular prism has 3 sides, so there's actually 3 faces that make this up. A pentagonal prism, the base has 5 sides, so there's going to be 5 faces, right? So an octagonal prism would have 8 faces, etc. Okay, so triangular prism, rectangular prism, square prism, also known as a cube, right? Decagonal prism. It's all about the number of sides the face, excuse me, not the face, the bases have. Okay? So then we have our lateral faces. And I've already talked about that. Those are the sides that connect the bases. And those are always going to be either rectangles or parallelograms. Now, because we are dealing with regular prisms, meaning this triangle is regular, this pentagon is regular, okay, meaning that all of the sides are the same, then all of our faces are going to be rectangles, okay? We won't have any kind of funky parallelogram faces. All of our faces for our prisms will be rectangles. So then when you have a prism, there's something called a net. And so a net is if I was to cut along the edges. So guys, what I mean by edges are the seams, right? Those are our edges, right? The lines that where faces are meeting or face meets a base. So if you were to cut the edges and lay the prism two-dimensionally, so flat, that's what we got, a net. So imagine you had an Amazon delivery box and you cut the sides and you cut one part of the top and you laid it so that the entire thing was laying on the ground. that would be a net. So here's a good two examples of here's a net of a triangular prism. So imagine if I took that and I was able to fold the top and the bottom up and the left and the right up, it would make a triangular prism. The one to the right of it, that's a rectangular prism. You have your base, and then this would be the side, 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 and a side. All right? So nets are helpful for understanding how prisms are put together. Technically, you could also always make a net to find the surface area, right? Because surface area is technically just the area of all of these things put together, right? Because surface area is all the sides that we can see. And imagine if I wanted to paint one of these prisms, everywhere that I painted would be the surface area of this figure, okay? So kind of just quick review here. Prism, three-dimensional shape, always has two bases, and then the number of faces is going to be determined by the number of sides that one of those bases has. And obviously both bases are always congruent. We name a prism based off the number of sides its base has. Lateral faces, or the faces, connect the bases, and the lateral faces for us will always be rectangles. And a net is when we take that three-dimensional figure, kind of cut it apart, and lay it flat on a surface. Okay. So surface area formula. So let's go ahead and have a triangular prism already laid out here. And so our bases for this triangular prism would be this front triangle and this back triangle. Okay? And our faces would be 1, 2, 3. So because we have 3 sides on our base, we have 3 faces, 1 for each side. And then just so I should probably mention this as well, these are called edges, right? So again, the segments, those are edges. So if I use the term edges, that's what I'm referring to. So our formula for surface area is going to have 3 variables. It's going to have a B, a P, and an H. Okay, so the capital B stands for the area of one of the bases. So here, this is also the part that's kind of tricky, is sometimes the variable stands for a formula, like the area formula, and sometimes the variable stands for just a length. So it's going to be really important for the surface area that you guys have a note card with all this information, super handy, or on a piece of paper, because it'll make taking your test go a lot smoother. Okay? So B is going to equal the area of one base, and remember that the bases are always congruent within a prism. The P represents the perimeter of one of the bases. That's kind of easy for us to remember. And then H is the height of the prism, aka the distance from base to base. Meaning, if this is a triangular prism, this length right here could be considered a height. It's important to note that all of these green lengths would be the exact same. Okay? So this formula works for any type of prism, whether it's a triangular prism, whether it's a cube, whether it's an octagonal prism. And our formula is 2B plus PH, right? So let's think about why this works. And it's actually broken up into 2 parts. This part right here is the area of the bases. Right? So it'd be the area of this triangle, and whatever I get there, I multiply it by 2 because the back triangle is the exact same size. Okay? The second part of our formula is the area of the lateral faces. And if you think about it, the reason why we do pH is because each one of the faces is a rectangle. And so imagine I wanted the area of just this side. I would need this length and this length right here, because rectangles length times width or base times height. Now, that rectangle is not necessarily the same size as this rectangle. However, because we have 3 rectangles, if we were to look at our net, it would be rectangle 1, rectangle 2, rectangle 3, all laid out. And this distance right here is this distance here. And then, excuse me, not there. That distance is, yeah, that was right, okay? This distance is this distance right here. And then this entire distance would be the perimeter of our triangle as it gets unfolded, right? So if I was to label these as A, B, and C, this would be side A, this would be side B, this would be side C. And again, if I was to fold them up, it would have that TP kind of look to it, all right? And so that's why the second part of our formula is P times H, because it's the perimeter of our prism times the height, because when I unfold all of that, all it is just one big rectangle. So let's do an example, okay? And the first thing you always want to do is find B, P, and H. So same diagram as we had up top. I know that this is a triangular prism. I know my height is 20, okay? I know that my base is an equilateral triangle. All 3 sides are marked as being the same, so the perimeter of my base is 30, 10 times 3. What I don't know is the area of my base. In order to find that out, I need to figure out what this distance is, so I can do base times height divided by 2, because that's our formula for area of a triangle. Okay, so I know this is an equilateral triangle. I know that that purple altitude is cutting this triangle in half. I also know that this top angle, because it's an equilateral triangle, is 60, which means that this angle right here is 30. So we do have to do a little bit of our math that we've been working on. This is a 30-degree angle. This side would be 5. This is 60. So based off our 60, 30, 90, or our right triangle trig, or, yep, those are only 2 things, either our 60, 30, 90 or our right triangle trig, I remember this is 5 rad 3. So 5 rad 3, 5 times the square root of 3 as a decimal is 8.7. So this is 8.7, which means the area of my triangle is 1/2 base times height. So 1/2 times 10 is 5. 5 times 8.7 is 43.5. So the area of one of my bases is 43.5. So now I'm going to go ahead and use my formula for surface area. So surface area equals 2 times the area of one of my bases plus the perimeter, which is 30, times the height of our prism. 30 times 20, it's going to be 600. And then 43.5 times 2 is 87. So 87 plus 600 is 687 units squared. And that is the area of all the faces and both bases of our triangular prism. Okay? So guys, these problems do take a decent amount of work depending on what information is given to you. Let's do another one. So here we have a rectangular prism. And the way that I normally do a rectangular prism is I normally say, okay, the side that's closest to me, or that's in front, and then technically I could look at it this way where that yellow's in the front and the top one's in the back, or I could look at it as this is being in the front and the bottom's in the back. It really doesn't matter. So first things first, the distance from base to base, so I'm going to have both my bases highlighted in yellow. So the distance between yellow to yellow is that 16 inches. So my height is 16 inches. My perimeter, well, if this is 12, then this is also 12. So the perimeter of my base is 15 plus 15 plus 12 plus 12 because opposite sides are congruent in rectangles. So 15 plus 15 is 30. 30 plus 24 is 54. So the perimeter of my base is 54. And then finally I need the area of my base. Well, it's a rectangle. It's just length times width, or 12 times 15. Gets me 180. So now we're ready to go, right? So it's going to be surface area equals 2 times the area of my base, which is 180, plus the perimeter times the height of our prism. 180 times 2 is 360. 54 times 16 is 864. 864 plus 360 is 1,224 inches squared. So finding the surface area of a rectangular prism is pretty easy, pretty straightforward. Okay? Let's do one more. And just so you know, guys, we're not going to do any pentagonal prisms or hexagonal prisms. We're mainly sticking with rectangular prisms and triangular prisms. Next one. So again, we have a triangular prism. My bases are the triangles. Now, one of the biggest things that people make the mistake of is they'll say, okay, well, I'm going to make this rectangle side my base, right? But think of this three-dimensionally. If I look across this, is there a shape that matches that rectangle directly across from it? And the answer is no. So this has to be a triangular prism. Okay, so here's our two bases. The distance between both of those is 5, so my height is 5. For our area, we can do, it's a right triangle, so I can do 1/2 base times height, 1/2 6 times 4. Area of a triangle, formula. Well, 6 times 4 is 24, divided by 2, so that's going to be 12. To find our perimeter is going to take a little extra work because we need this yellow length to get our total perimeter of our base, right? So I'm just going to do Pythagorean theorem. I'm going to call this y. So 4 squared plus 6 squared equals y squared, because y is the hypotenuse. So 24 plus 36 equals y squared. 24 plus 36 is 60, so y squared equals 60. And because we're doing surface area, we're going to go ahead and get the decimal amount of that. I'm going to take the square root of 60, so my hypotenuse length is 7.7. So then my perimeter is going to be 4 plus 6 plus 7.7, or 17.7. And once I have that information down, I can now use my formula. So surface area equals 2 times the area of my base, which is 12, plus my perimeter, 7.7, times my height. 2 times 12 is 24. 17.7 times 5 is 88.5. 88.5 plus 24 is 112.5 inches squared. And so, guys, for the most part, the rectangular prisms will be pretty quick. The triangular prisms, you might have to do a little bit extra work to find some type of missing dimension. Good luck. Let me know if you have any questions.